Now we're going to start part 3, which is the last part in this topic. Here we will cover types, trend, and approach towards developing information system, and at the end we will have summary for the whole topic. What is IS development methodologies? It is a comprehensive guidelines to follow for completing every activity in the system development lifecycle, including specific models, tools, and technique. Here, there are 7 IS development methodologies and its example. Number 1, process-oriented. For example, Stradis methodology, Gain and Sasson methodology, Youden system method, and Jackson system development. Number 2, blended. For example, structured system analysis and design method. Number 3, object-oriented, such as Buch methods, OOSE, OMT, Unified Approach Methodology, and Rational Unified Process. Number 4, rapid. For example, James Martin's RAD, Extreme Programming, and WebIS development methodology. Number 5, people-oriented, such as Common CATS, Ethics, and CATS. Number 6, organizational-oriented, such as Soft System Methodology, IS Work and Analysis of Changes, Process Innovation, and Project in Control Environments. And lastly, number 7, framework, multi-view, strategic option development and analysis, and capability maturity model. Next, we will learn about system development lifecycle approaches, such as traditional system development lifecycle, object-oriented system analysis and design, and case system development lifecycle. There are 2 general approaches to system development. The first one is the traditional approach or structured approach, and the second one is object-oriented approach. All system developers should be familiar with these 2 general approaches because they form the basis of virtually all the other methodologies. Object-oriented system analysis and design. It is an alternate approach to the structured approach of the SDLC that is intended to facilitate the development of systems that must change rapidly in response to dynamic business environments. The analysis is performed on a small part of the system, followed by the design and implementation. The cycle repeats with analysis, design, and implementation of the next part, and this repeats until the project is complete. Here we can see a few examples of structured methodologies and object-oriented methodologies. We have Stradis, SSADM, JSD, YSM, and more. For object-oriented, we have Buch, OMT, OOSE, Unified Approach, Rational Unified Process, and more. Here we can see the difference between structured and object-oriented. You see here the problem. The structured will focus towards the process itself, while for object-oriented, it will be focused towards the object. What is case tools? Case tools are productivity tools for system analysts that have been created explicitly to improve their routine work through the use of automated supports. There are 4 reasons for using the case tools. First is to increase analyst productivity. Second, to improve the analyst's user communication. Third, integrating lifecycle activities. And fourth, accurately assessing maintenance changes. This figure shows the case tools classification. We have 2 main types. The first one is the uppercase. The second one is the lowercase. And both of them is called integrated case. In the uppercase, we have planning, analysis, and design. The uppercase tools perform analysis and design and mainly for analysts and designers. For lowercase, we have implementation, testing, and maintenance. For lowercase tools, it generates programs from case design and mainly used by programmers. integrated case perform both upper and lower case functions. Now we focus on the uppercase tools. Why is it important? It is important in order to create and modify the system design. It also helps in modeling organizational requirements and defining system boundaries. Besides that, it can also support prototyping of screen and report design. As for lowercase tools, it is important in order to generate computer source code from the case design, and the source code is usually generated in several languages. Here we can see the differences between the traditional versus case system development lifecycle. Both have 5 phases, but here is the main difference in program design and coding for the traditional and uppercase toolset for case system. If you can see, in the traditional system, in program testing and installations, you can still go back to the previous phase to fix installation bugs and program bugs and error. But for case system development, it will go directly towards lowercase toolsets, the code generator, and then you will have an error-free computer system for the installation process. There are several alternate system development lifecycle approaches, such as Agile approach, prototyping, ethics, project champion, soft system methodology, and multi-view. From this figure, you can see the main components of methodology. First, we have techniques, then we have tools, and then we have models. What is techniques? Techniques is a collection of guidelines that help an analyst complete a system development. It consists of 6 main samples: strategic planning, user interviewing techniques, data modeling techniques, software testing, project management, structure analysis and design. What is tools? Tool is a software tool that helps create models or other components required in the project. There are 6 main samples of tools. We have case, drawing graphics applications, reverse engineering tool, code generator tool, database management application, and word processor. What is model? Model is a representation of some important aspect of the real world. There are 6 main samples of model. The first one is flowcharts, and then followed by data flow diagram, entity relationship diagram, structure chart, class diagram, and sequence diagram. Now we've come to the topic summary. As you know, information is a key resource towards the organization. System analysts deal with many types of information systems across the organization. You now see the importance of the integration of the traditional systems with new technologies, and you must understand the roles and qualities of the system analyst. You also must now have greater understanding of the system development lifecycle and case tools, and recognize the alternatives to structured analysis and design and to the SDLC. This slide shows the overall picture of system analysis and design. As you can see, you must go through a step-by-step process in order for you to make the final output or present your system. This slide is based on Kendall and Kendall 2014 book named System Analysis and Design 9th edition. You can find this book and use it as your main references and to get more understanding. Now we have come to the end of the lecture. Feel free to ask anything, and I think you can use the references to get more understanding of this subject. Thank you.